Okay, hi everyone. Today we'll be studying carbon and its compounds. Alright, carbon is present everywhere, it is omnipresent on this earth. Everything is based on carbon. I am made of carbon, you are made of carbon, everything is made of carbon on this earth. Alright, naturally occurring things, our life is carbon based. We consume food that is carbon based. Every body part of us is carbon based, even our hair, everything is carbon based. Alright, so carbon also occurs in various compounds on this earth. Alright, we all see, we get petrol, we get fuels, there is pollution as well. So what is all that? How is all that coming from? It's coming from carbon. Okay, carbon is an important element in our earth. Okay, so carbon, and we will study its various compounds. So let's get into it. Allotropes of carbon. So carbon exists in various forms. Okay, not everything is just carbon. See, carbon exists in various forms, and these forms are called allotropes. Allotropes of carbon. Allotropes are different forms of an element that exist in the same physical state but have different structural arrangements. So I'll tell you, there are three allotropes of carbon. They exist in the same state. Same state means solid. Solid, solid. Okay, but their structure would be different. Structure would be different. Alright, so such allotropes we'll be covering. Carbon exhibits several allotropes, including diamond. Diamond is an allotrope. Okay, graphite, lamp black, and gas carbon. Okay, let's get into each of these individually. Diamond, we all have seen diamonds. Okay, this is a very highly polished, shaped diamond. It does not naturally occur like this. It is quite losing shine, but when it is given shine, when it is worked on by an artist, it will look like this. So diamond is a well-known allotrope of carbon. It consists of a three-dimensional network of carbon atoms bonded together in a tetrahedral arrangement. Tetrahedral, I'll show you a tetrahedral arrangement. This, see over here, this is tetrahedral. Okay, what do you mean by tetrahedral? Each carbon is connected to four other carbons. Each carbon is connected to four other carbons. Each carbon is connected to four other carbons. Okay, so like this, 1, 2, 3. This is a carbon, it is connected 1, 2, 3, 4. Okay, this is a carbon connected to 1, 2, 3, 4. Again, this over here, 1, 2, 3, and 4. Okay, so this will be like this. It is a tetrahedral. Tetra means 4. Okay, tetrahedral. Each carbon atoms 4 covalent bonds with its neighboring carbon atom, resulting in a very rigid, strong structure. It is very strong structure. It is the hardest substance found on the earth. Due to its hardness and high refractive index, if you've seen light, high refractive index, okay, it bends light a lot. Okay, it has a high refractive index, it goes total internal reflection, so it shines a lot. You see this, each surface is shining differently. Okay, diamond is widely used in jewelry and industrial applications. Widely used. Graphite. What is graphite? Graphite is another allotrope of carbon. Unlike diamond, graphite has a layered structure in which carbon atoms are arranged in hexagonal rings. What is hexagon? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 6 faced is hexagon. Okay, if you see this 1, 2, 3, 4, 5, 6. 6 sides, 6 bonds. Okay, this layered structure, okay, is of graphite. The layers are held together by weak van der Waals forces. The forces that are holding these layers together are called van der Waals forces, and these are weak. So graphite can also be graphite has a oiling liquid, a lubricant. It can also be acted as a lubricant. Graphite can also be solid, but not that solid as diamond. Diamond is very hard. Okay, so allowing them to slide over each other. So these layers can slide over each other. Graphite is soft, black, and a good conductor of electricity. It is used in pencil leads, lubricants, and electrodes. Okay, pencil leads. Can you see this? This is graphite. It is also used in machines. Why? As oil, as a lubricant. What is lubricant? So that the parts don't break down together, they don't go friction, but there is some smoothness to it. Okay. Electrodes. It is also used at electrodes for electroplating. Alright. Lamp black. What is lamp black carbon? Lamp black is a fine black powder composed of the purest carbon. This is carbon in purest form. Purest. Okay. It is produced by incomplete combustion or the deposition of soot. Soot. When we burn soot, okay, incompletely, okay, this will result like this. Soot is an organic compound, okay, like plants and okay. So lamp black is often used as pigment in inks, paints and dyes. Since it is really black, we use it in paints, okay, we use it in inks, we use it in dyes. Recently someone had started a business that he will take the pollution of cars. Okay, so if there is a car, from when you see it from the back, okay, there is a silencer over here, okay, and this is the back of the car. All right, so he came up with a device that he would put over here and it would take all the pollution coming out from it, okay, keep it in a box, and that pollution, that carbon that was emitted from the car can be used to make inks. Okay, so similarly lamp black is used to make inks. Gas carbon. What is gas carbon? Gas carbon refers to amorphous carbon with irregular structure. Amorphous, having multiple structures. Carbon with irregular structures. It is obtained as a byproduct. Amorphous means it does not have a proper structure. Okay, so gas does not have a proper structure. We can see gas at our homes. Alright. Does it have a proper structure? No, it's just burning. Alright. So during the production of coal gas or as a residue in the petroleum refining process, gas carbon is used in manufacture of electrodes, dry cells and various carbon based products. How do we obtain gas carbon? When we extract oil, crude oil from the earth, there is a byproduct. Alright, we get byproducts from everything. Okay, you're doing one process, you get some other process as a byproduct. Okay, so gas carbon is a byproduct. When we burn coal or we get petrol, gas carbon is also produced. It is used in these places. Non-crystalline forms of carbon. So now, till now we were in crystalline forms. Now we are in non-crystalline forms. Okay, coal is a natural solid fossil fuel formed from the remains of ancient plants that lived millions of years ago. So how do we got this? How did we get this black substance? Plants, animals, millions of years ago they died. Okay, there were earthquakes, their remains went into the earth, alright, deep into the earth, where it was under very high pressure, under very high heat, and it got converted into this. Okay, so this is coal. It is natural, it is a fossil fuel, it is derived from fossils. It contains mainly carbon along with small amounts of hydrogen, sulfur and nitrogen. So coal does produce pollution, okay, but coal has majorly carbon. If you see over here, it has major carbon but has small amounts of hydrogen, sulfur and nitrogen as well. Coal is extensively used as a fuel for electricity generation. Delhi or major states, they use coal for electricity generation because it gives out a lot of energy. We use that energy to use the generators, and in turn, alright, to move the motors, to move the dynamos, and in turn we get electricity, okay, in industrial processes and for heating purposes. So we use coal in our households as well, but also in industries. Now we come to Coke, not that Coca-Cola, we come to Coke. See how this one is a little bit shiny, this one looks more pure. Coke is porous solid obtained by heating coal in the absence of air. Okay, when I take this coal, okay, when I take this coal and I heat it without oxygen, okay, so when I heat it without O2, means anaerobic, without O2, it becomes like this. It is primarily composed of carbon and is used as a reducing agent in the extraction of metals from their ores. So where is it used? When supposedly metals are also not found in a pure state, okay, metals you will find reacted with something, okay, in the form of ores, mineral ores, okay. How do I extract this metal from this mineral? I use coke, I heat it using coke, okay. It is used in blast furnaces, it is used in the production of steel, okay. What is steel? Iron plus carbon. What carbon? This coke, alright. Charcoal. Now charcoal is produced by heating wood in the absence of air. So you might think this is coal. No, this is charcoal. What is charcoal? You take wood, you heat it without O2 and it will turn this black, and you can use it to produce heat, you can use it for cooking, you can use it for tandoor and all, okay. So it consists of mainly carbon and is commonly used as fuel for cooking, heating, industrial processes as well. Charcoal is also used as an adsorbent in water purification systems. Charcoal has a property, okay, of soaking in impurities. It is called an adsorbent. See this word, adsorbent. It adsorbs, okay, all the impurities. Supposedly there is a toxic gas, poisonous gas in a room, okay, and I place some charcoal in that room. So the outer surface, okay, supposedly this is a log, charcoal, okay, this outer surface will take in that poisonous gas. This is the adsorbent property. In earlier days, I'll tell you, people used to brush using ash. You see this ash? Why? It is considered to be one of the purest things. It does not have any germs. Alright, it is just burnt ash. You can use it. So people used to do that. Even if you see some toothpaste, they say they have charcoal in it. Why charcoal? It has a cleansing property. Okay. Oxides of carbon. Now we come to the important oxides of carbon. Carbon dioxide, CO2. Okay, we give out CO2 due to respiration. It is used by plants. Alright, you see the system here over here. Okay, so the two types of oxides will be carbon dioxide and carbon monoxide. I will go into the detail of both. Carbon monoxide. What is carbon monoxide? Carbon monoxide is a colorless, odorless gas composed of one carbon atom and two oxygen atoms. So it is colorless, no color, odorless, no smell. How is it looking? Carbon and two oxygen. Okay, CO2. This is how it looks. Covalent bonding. Okay, covalent bonding. These are two non-metals. It is produced during combustion, respiration and other natural processes. Whenever you burn something in the presence of oxygen, whenever you burn carbon, oxygen, heat, you get CO2. What is our body doing? Okay, I am taking in oxygen, I am carbon based and I am giving CO2. Okay, I'm burning the food inside. Okay, what I consumed, I'm burning it, and CO2 is being produced. Food is carbon based. Carbon dioxide is a greenhouse gas and plays a significant role in Earth's climate system. CO2 is very important to have seasons, to have weathers and all. It is also used in fire extinguishers. Okay, if you put CO2 over a flame, right? Fire, it will stop burning. Okay, so carbonated beverages, Coca-Cola and all. Okay, carbonated beverages. Carbonated means you see that gas, it is carbon dioxide, CO2. It is also a coolant in some industrial processes. Carbon monoxide, what is the formula of carbon monoxide? It's CO. Okay, CO. It is only connected to one oxygen. Alright, carbon monoxide is a toxic gas that forms when carbon containing fuels are incompletely burned. So when we burn carbon or coal in absence of much oxygen, okay, it will form CO. Okay, carbon monoxide is a toxic gas. What do I mean by toxic? If you inhale it, it will be harmful for you. So incompletely burned, what do I mean by incompletely burned? In less oxygen, it was not completely burned. Okay, it is produced by vehicles, stoves, furnaces and other combustion processes. There is something known as an angeeti. Alright, people use to put coal on it, burn that angeeti, and the coal would last all night long. In cold areas, that serves as a purpose of heat. Okay, purpose of heat. If you put it in a room, you close all the doors and windows, there is no oxygen. What will happen? That coal burning will produce carbon monoxide, CO, which causes you these problems: breathlessness, dizziness, you will feel like vomiting, you will feel like passing out, you will feel like nauseous, headaches, collapse, loss of consciousness. I have felt that. Alright, I have felt carbon monoxide, and this also happened once. That one family they had an angeeti in their home, they closed all the doors and they slept, and all of the family died because of carbon monoxide. It is dangerous. Okay, so whenever you are burning something, make sure there is a lot of oxygen present. Carbon monoxide is highly poisonous and it binds to hemoglobin in the blood. It will go in your blood, it will bind to the hemoglobin, it will reduce the oxygen carrying capacity. Why is all this happening? Why? Because there is no more oxygen being supplied to your brain, to your blood. Proper ventilation and use of carbon monoxide detectors are essential to prevent accidental poisoning. Okay. Now we come to petroleum. We all know petrol, our cars, bikes, everything use petroleum. How do we get petroleum? You see this extraction, there is a lot of petrol under the sea. Alright, a lot of petrol under the sea. Crude oil it's called. We take this crude oil, we take it to a refinery. This is a refinery where we extract petrol from crude oil and other products like natural gas and methane and all, CNG and all. Okay, all that comes from crude oil. Okay, petroleum is also known as crude oil. It is a naturally occurring fossil fuel composed of hydrocarbon compounds. What do I mean by hydrocarbon compounds? That had carbon and hydrogen. So like CH4, natural gas. Okay, it is formed from the remains of ancient marine organisms. What are ancient marine organisms? All those plants and animals that died from prehistoric ages. So like from dinosaurs ages, they all died. Okay, and they went inside the earth. It was covered later on by a lot of land, earthquakes and whatnot, and the earth undergo many processes, and we get this fossil fuel millions of years later. Okay, petroleum is a complex mixture of various hydrocarbons including alkanes, cycloalkanes, aromatic compounds. So you need not go into all that, but petroleum has a lot of compounds in it, and majorly it's carbon and H2. Alright. What are the constituents and uses of petroleum? Petroleum consists of different fractions of gasoline, diesel, kerosene, lubricating oil, bitumen, each with its own range of hydrocarbons. See, all of this is obtained from petrol. Gasoline is used as a fuel for automobiles. Okay, see, gasoline, while diesel is used in diesel engines. Kerosene is commonly used as a fuel for jet engines. Okay, kerosene is normally used for jet engines and lamps. It is very calorific. It produces a lot of energy, a lot of heat. It catches fire very easily. So kerosene is used mostly in jet engines and lamps. Lubricating oil. We get oil, lubricating oil from petroleum. It reduces the friction between moving parts. Alright, it reduces friction between moving parts. So supposedly this was some machine part and this was some machine part, and they had some contact. To reduce friction, I will pour oil, lubricating oil, so that it does not undergo any more friction. Bitumen is used in road construction and waterproofing. Alright, so bitumen is something that is used in road construction and waterproofing. This is a kerosene lamp, this is kerosene. Alright, now fuels. Let's come to fuels. Alright, fuels are substances that release energy when burnt. Okay, so everything that gives you energy when burnt is fuel. Okay, so carbon based fuels are widely used for various purposes. Alright, carbon based fuels are mainly used for various purposes. So like heating, cooking, electricity generation and transportation. CNG, petrol, diesel, gasoline, these are all carbon based and are used for various processes. Some common carbon based fuels include water gas, okay, producer gas, oil gas, coal gas, natural gas, LPG cylinders we get at home, and biogas or gobar gas. This is used in rural areas. So let's get into the depth of it. Water gas. Water gas is a fuel gas produced by passing steam over red hot coke or coal. Okay, so supposedly there was some coal over here. Okay, consider it a pile of coal and it is red hot. I take a container having steam. Okay, pour that steam all over this. This will all burn, steam and all, and this will be very hot, very high in energy, this gas, and this is water gas. Okay, this is water gas. Water gas, it mainly consists of carbon monoxide and hydrogen and is used as a fuel in industrial processes. Okay, if you must have seen Titanic, alright, if you've seen Titanic, they were using water gas, alright, steam, water gas. Okay, this was all being used. Producer gas. Okay, so producer gas is produced by passing air over red hot coal or coke. Okay, so producer gas is produced by passing air over red hot coke or coal. It is a mixture of carbon monoxide, nitrogen and small amounts of hydrogen. Okay, producer gas is used as a fuel for industrial heating in gas and in gas engines. Okay, industrial heating. Now we come to oil gas. Oil gas is obtained during the refining of petroleum. Like I told you, when we go into refineries and we find petrol is being used, we get a lot of byproducts. What are these byproducts? Oil gas is one of that. Alright, it consists mainly of hydrocarbons. It consists mainly of hydrocarbons, including methane, ethane, propane, butane. These are all names of hydrocarbons that are obtained. Oil gas is used as fuel for heating and cooking purposes. Oil gas. LPG, liquefied petroleum gas. Okay, LPG is a mixture of propane and butane. Okay, propane and butane. These are two hydrocarbons, just remember the name. Gases that are liquefied under pressure. These are liquefied when supposedly there is some gas over here. These are gas molecules. I took up pressure, okay, and I put it down. Okay, so this will come out like this. Molecules over here. Okay, I have put some pressure over here. This is now liquefied. Liquid. LPG is stored in pressurized containers and is highly portable. The gas containers, the cylinders that you get at home that has LPG. Natural gas. What is natural gas? Natural gas is a fossil fuel primarily composed of methane. What is methane? CH4, natural gas, which small amounts of other hydrocarbons. So it has some other as well. It is typically extracted from underground reservoirs. Okay. It is typically extracted from underground and is used for heating, cooking, all the domestic purposes, electricity generation. Natural gas is considered a cleaner burning fuel compared to other hydrocarbons. It is relatively cleaner. Okay. Biogas. What is biogas? Biogas is also called gobar gas. You take gobar, cow dung and all. It's a mixture of methane and carbon dioxide. Okay. So you take that and you burn it, it produces heat, energy, methane, carbon dioxide. So biogas is a mixture of methane and carbon dioxide. Okay, methane, carbon dioxide produced by the anaerobic. What is anaerobic? Without air. Okay, without air or oxygen, no O2. Anaerobic decomposition of organic matter such as animal dung, gobar, agricultural waste like what is the left out of cutting the crops, sewage, okay, all the drains and all the sewage, all the waste that goes from our households. It can be used to produce biogas. It is used as a renewable energy source for cooking, heating, electricity and generation. Okay, so it is renewable. All right, there is abundance of it. It is a renewable resource. Okay, we can use it again and again. So yeah, so that will be enough for carbon and its compounds. Thank you.